Hi guys, so I'm creating this video to accompany the worksheet or the chapter which I created on subject of formula. So this video should help you to go through the chapter, and actually it's going to give you a bit more detail about the steps involved in the chapter. So I'm going to first go through the main steps before we move further with the explanation. So when it comes to making a variable subject of formula, there are three key steps. And key step one, which you can see on the screen here, is actually identifying the current subject, which is the dependent variable. It's basically what's the current subject of formula. So here it's y, because you have y in terms of x. So y is the main character here, okay? And step two is identifying the new subject, meaning what do we need to make subject of formula here. And then step three is about the process itself. So once you've determined what you need to make subject of formula, you need to actually isolate that variable. So you'll see that the key word here is isolation. So how do we isolate that new variable so that it becomes the new subject of formula? So let's look at example one from the textbook. So we have y is equal to 3x plus 2, so y is the dependent variable here. The goal is to make x subject of formula. So you need to isolate the x. And what we are doing here in the steps is we are subtracting 2 on both sides, because subtracting 2 on both sides gets rid of the plus 2. And then they're dividing by 3 so that the x becomes subject of formula. So I'm just going to demonstrate that on the board so that you can clearly see what's happening. So we had y is equal to 3x plus 2. Y is equal to 3x plus 2. So the first step is they subtracted 2 on both sides. And it's an equation, so whatever you do to the left, you need to do to the right hand side. So y, you subtract 2, it stays y minus 2. Here on the right hand side, it's 3x plus 2, and then you're subtracting 2, so minus 2. So you end up getting y minus 2 is equal to 3x. The plus 2 minus 2 cancels out. So we were able to eliminate the 2 which is on the right hand side by actually subtracting 2 on both sides. Alright? Now we need to make x subject of formula. So the whole process is about actually isolating the x. Okay, because this needs to become the new subject of formula. So we'll try to do everything so that we can have the x on one side. So we need to isolate that x. We got rid of the plus 2 by doing minus 2 on both sides. Now we need to get x, then there's a 3 in front of it. So to eliminate that 3, we need to divide by 3 on both sides. So if you divide by 3 here, you divide by 3 on the right hand side. What will happen is that the 3 will cancel out, and you will get x equal to 1 minus 2 over 3. Alright, so this is what was applied to this equation if you refer back to the chapter from the book, whereby we tried to first introduce minus 2 to eliminate the plus 2. And then we divided by 3 to eliminate the 3 which was in front of x. Okay, so if we go back, this is what we actually got, y minus 2 over 3. So here we're solving it, and we're actually introducing a new parameter on both sides so that we eliminate one of the numbers here. First we eliminated 2, and then we eliminated 3. So that's one way of looking at it. Otherwise, there's a more direct way of looking at solving equations where you're moving terms around. So I'm just going to explain to you an alternate method, which is quicker. This one may be more logical in terms of you're trying to balance the equation, and you can clearly see what happens when you introduce a new operation on both sides. There's a more direct way whereby you're moving terms around. Now, if you're going to use the second technique, you have to understand what's the operation involved and what's the inverse of the operation. Meaning, if you're moving terms around, a plus will become minus. a multiplication will become division when you send it to the other side. Okay, so let me show you how it works. So you have a +2 here on the right hand side. You need to move it to the left. Okay, so if you move +2 to the left, plus will become minus. And you're left with 3x on the right hand side. Now the aim is to get x. So to get x, we need to move the 3 to the other side. Now in 3x, you actually have a multiplication between the two, the number and the term. So times 3, if you send it to the left hand side here, it becomes divide by 3. Okay, so there are two key steps which happened. First, we moved the +2, it became -2 on the left hand side. Then the times 3, when you move it to the left hand side, it became divided by 3. And we end up getting the same answer we got in the previous in the previous method. So you've been exposed to different methods, and now it's up to you to really choose which one you like to pick. So there were actually two manipulations in the first example. The second one also, it's more or less the same technique. So here you can move the +5 over there, it becomes -5. Then it's times 4, you move it to the left, it becomes divided by 4. What I like doing is I like keeping things on the same side. So I would never write the final answer as this. I would move the 4 to the left hand side so that on my left I would have 3p minus 5 divided by 4, and then on the right hand side it's just q. I don't like showing it this way, but that's a common approach. That's why in the chapter I've kept it like that. It's a very common approach to actually write the new Subiaco formula on the left. All right. Now I'm going to to demonstrate one with multiple operations also, which is one like this. So m is equal to n over 2 plus 3. Let me show that to you on the board. Okay, so we had m is equal to n over 2 plus 3. And we need to make n subject of formula. Subject of formula. Okay, so we can use the direct approach, which I just showed you. So +3, if you move to the left, it becomes -3. So m minus 3 is equal to n over 2. Then divided by 2, if you move to the left hand side, divide by 2 will become times 2. Now we need to be careful here. When the divide by 2 goes to the left hand side, it becomes times 2. But it's times 2, it's the whole expression multiplied by 2. So it's n minus 3 in bracket times 2. This is what n is. Okay? And you can keep it in factorized form, or you can actually expand it. So if you expand, 2 times m is 2m, 2 times -3 is -6. So that will be the new expression we have to get. Okay, so you see they've kept it in, I've kept it because I created that. So we can keep it in factorized form, or we can actually expand it. Okay, and there's a fourth example here, the final one, whereby you have a negative coefficient. So let's try this one also. So r is equal to 5 minus 3s. Let me try that on the board. So r is equal to 5 minus 3s. So we would move the 5 first. It becomes -5, and when it goes to the left, and what's left on the right hand side is -3s. We need to make s Subiaco formula. So this is multiplied by -3. If you send it to the left, it becomes divided by -3. Okay, and that will be the expression. Now to make it look nicer, what you can do is you can multiply the numerator by -1, and you multiply the denominator also by -1, so that -1 times r is -r, -1 times -5 is 5, divided by -1 times -3, which is +3. And -r plus 5 can be written as 5 minus r divided by 3. It just makes the equation look nicer, but actually you could stop over here where you have r minus 5 divided by negative 3. All right? So I've gone through the 4 examples from the chapter, and then you have a couple of practice questions which you can do. You have the answers to check, and then it's quite a massive worksheet, this one, and I've created it in such a way that you have different levels. So you have easy, advanced, hard, and then of course you have a very hard section. So there's lots of practice in this worksheet. Try to make the most out of it and do all the questions you can, so that you can successfully complete this section of the course. All right, so good luck with that.